Hi guys, my name is Ndjido Ardo. I think everyone is can hear me correctly. I'm just gonna check the comment. Guys, I need your feedbacks on the quality of the audio. So if it's not good enough, let me know. So I'm going back to my slides. So tonight I'm going to tell you about machine learning, doing some machine learning using a tool provided by Google, developed by Google, that's named MLKit. And we're going to be using MLKit in Flutter. So the agenda is this one. I'm going to talk about myself quickly and the company I'm working with very, very briefly. And then I'm going to have a quick presentation of Flutter. So this presentation is not dedicated to Flutter, but I'm just going to have an overview of what it is, because that's the main tool that will be running our machine learning algorithms. I'm going to have a presentation on MLKit. So MLKit is mainly a tool that we're going to be using to run some machine learning algorithm inside Flutter. And I'm going to demo a real life application and to show you the real flavor of what it is, what it takes to run such a model provided by MLKit inside a real life application. And lastly, I will have an overview of TensorFlow Lite, which is indeed an extension of whatever you can do ready-made inside machine learning kit, MLKit. So who I am? I'm a Google developer expert in machine learning, and I'm working as a CTO in a digital group named Dscale. I'm one of the co-founders indeed. So we are mainly focused on IT and machine learning and data in general. So we help companies in UAE, all the MENA region, in infrastructure, in data engineering, and to build artificial intelligence models, and also to build application. Thus, that's why we're using Flutter as one of the tools. And of course, in the backend, we mainly use Golang to develop APIs. So without any further ado, I would introduce quickly what Flutter is. So Flutter is a tool, is an SDK for developing high performance and high fidelity application for both iOS and Android, and even now web. And indeed, today you can develop web and desktop application, which are beta and preview. And this gives you an overall ecosystem of addressing different kind of devices and different kind of people, indeed. So that's why it is powerful. And the reason why Flutter is interesting to use is it is notoriously unaffordable to build an application by having different teams, like a team for iOS, a team for Android, and even a team for web and whatnot. So this is definitely very expensive to maintain a different flavor of one single application that most of often the case, it has the same origins that need to see the same kind of output. So Flutter gives you definitely this powerful native experience by definitely giving the developers the ability to have control on every single pixel of the application they're building. And on the other side, on the customer side, they will be having pretty much the same experience based on which platform they are, which is really great. So Flutter, just an overview of the technology stack behind Flutter. Flutter is based on several low-level C and C++ engine like Skia, Text, and using Dart as a language. And it's leveraging all this to build 2D kind of output with 60 frames per second, which is really fast for such a device and such application. So the power of this is that you have control on every single pixel and of your screen and of your application that give you doors open to a lot of productivity and a lot of creativity. So on top of this low-level engine, you have all the Dart framework, which mainly based on widgets. So indeed, in Flutter, everything is a widget. It's like redefining the object-oriented paradigm by using widgets. So widgets is the object you're using all of the way. Everywhere, whatever you're doing in Flutter, you're using objects. So it can be animation, text, images, whatever you think about is a widget indeed, which makes it much more easy to use if you compare it to something like the CSS in the web world. So Flutter doesn't only serve the development of application in a mobile application in iOS and Android. It also gives you the ability to develop web application. For example, you can develop progressive web apps by using the web component of Flutter, and it leverages some low-level components, just like in the previous slides. It's used Canvas, JS Engine, and the DOM just to build and use the same mechanism of widgets to allow you to have much more flexibility and give you much more easy to use tools inside the web environment. So definitely what Flutter Web is doing is building the application and translating it and translating the application into the CSS HTML world. So which makes it very, very powerful. And the thing is, if you are familiar with CSS, CSS is notoriously hard to learn because they have some like tricky things that are not straightforward. While in Flutter, definitely whatever widget you see and the way it's described is pretty much what you're getting as an output on your screen, on your UI. So which makes it much more flexible. As far as my experience is on the web development, I've been using like Angular, I've been using a lot of other frameworks like React, but when it comes to combining React and other CSS, is notoriously hard to build a very nice UI interface, and Flutter Web makes it easy to have one code base for your native application, but also promote it to a web application or even a progressive web app. I'm gonna check if they have some questions in the live quickly. Okay. Okay, cool. So now MLKit, what is it? ML means machine learning indeed. So MLKit is just a framework. It's a tool that take advantage of all the experience that the Google's teams have leveraged, all the experience they have in building sophisticated machine learning models like face detection. So we know that building a machine learning algorithms or model to detect face is notoriously hard, and it needs a lot of example in based on the ethnicity, based on different shape, different texture, and so on and so forth. And this is notoriously hard to build. If you are in the machine learning world, you know that most of the time you use some combination of CNN and LSTM and all that complicated model, but the model is one thing, and building it and finding the data to build it is even another bigger model, because it needs most of the time a lot of computation power, and most of the companies or simple developers do not have or do not bother having it because it's not their job to build the models. They just want to have an algorithms or model ready to be used. So that's why MLKit comes into the place, and it's allow you to use ready-made machine learning algorithm that have been developed by Google. So this is a few example of the capability of MLKit. It's image labeling, object detection and tracking, code bar scanning, text recognition, on-device translation, and lately we have this language ID and smart replies. So, and you can do even more because MLKit opens the door by providing you the ability to embed or use a TensorFlow model you already developed. So TensorFlow quickly is a machine learning framework that allows you to build machine learning algorithms one shot indeed. So you need to build it once and you can prototype and put it into production as far as you have a very good accuracy. So once you build your model in TensorFlow, TensorFlow Lite is this process, is this tool that allow you to bring a machine learning algorithm that have been built with TensorFlow, translate it into a much shrunk model, a much lightweighted model, I would say, and embed it in a IoT device or any device like for the phone. And the MLKit gives you the capability to run on device, so without any internet connection, or you can also run in the cloud. So the big difference is that in the cloud, in Firebase, basically the model you are calling in the cloud in GCP is hosted in Firebase, and I think it is free for the first 1,000. And what I want to mention that is the difference between running on device and calling some APIs in the cloud in Firebase is that the model in Firebase is much bigger, of course, and it has much accuracy. I won't say much more, but it has significantly much accuracy than running it on a device. But of course, what you earn in the device is the privacy, and you're not compromising that much about the quality and the accuracy of the model, which is a good fit. And it depends on the use case, and you need to have the trade-off of compromising privacy against, and which is debatable, of course, because there is still just debate between the privacy in the cloud and on device. Definitely on device is much more private, and because you're not connecting to internet. But yeah, of course, there is a trade-off you need to make based on the use case. I would like to go through an example. So sorry guys, this is some code. It's in Dart. This is the first example of using MLKit in Flutter. So what you see here is on the right-hand side is my Emirates NBD. So if you're living in UAE, my business is in Dubai. I'm living in Dubai, and one of our partner give us this exercise, and this exercise to extract some information from the card. So this is the Emirates NBD, and the Emirates ID. And in this Emirates ID, we need to extract some information like the name, the nationality, the ID number, and even the photo of the user. So the idea is here, we're using MLKit, we're using few example, we're using few objects, I would say, of MLKit to extract this information. So in this example here, what we're doing, we're trying to extract three information. The first information is the ID number. The second information is the name of the owner of the card and the nationality. These are main three information. If, for example, you are in a banking application, you need to extract to be the KYC or something else, and to make it easy for the users to onboard in the application or to register in the application. So here, what you see as a code is quite basic. You have two kind of blocks. The first block is building, loading some model. So here it is from an application my team and I are building in Dubai for one of our partners. So what we're building here is we're loading some text, some image from the camera on the device. It can be an iOS and an Android device. And this object is provided by this Firebase Vision object. And we can use this from file path to load an image that have been already taken by the camera. So this document image will be used by an algorithm. So to get one of the instance of the recognizers. Indeed, in MLKit, you have a lot of recognizers. You have face recognizers, you have landmark recognizers, text recognizers. This is for OCR, for extracting some text, or detecting some text. We're using this text recognizer object. And from this text recognizer object, we call asynchronously this document image by using this process image. So what it does here, the algorithms, the built-in algorithm inside MLKit is going to try to detect every text inside this algorithm. So what we're doing here, once this line have been have finished extracting the information, have done its job, maybe successful or not successful based on the quality of the image and so on and so forth. What we're doing, we're going through this block. I would say this block iterable, and for each block we have lines, and these lines, what we're doing here, we're using this set state, which is a method inside a widget, which is what we call the stateful widget. A stateful widget is just one of the widgets available in Flutter that allow you to update the widget on the go. It is performance-wise, it's a bit like borderline, because you can use other state management tools like the block, which is my favorite one. I'm using all the time with provider and so on and so forth. So here, what we're doing inside this set state is we defining some pattern. For example, we need to extract the date, which is at the back of the card. Here we're not using it. We extracting the sex also from this card. Also, we extracting some date. We have some date from this from the card as well. I think it's more the back hand side of the card. So recycling through these two components, the blocks and the lines of the blocks, to extract this information. Of course, you need, once the job is mainly done at this level, so at this line, the final document equal await and text recognizer that process image, and then the algorithms are on the device is extracting the information, and then you can do whatever you want from this result. And of course, based on your use case, you need to define patterns. Just like what I'm doing here, you need to define some length of some text you want to extract. Generally speaking, you're going to be defining some pattern in extracting them kind of manually, not that manual, but that programmatically you're doing it, but it's based on some patterns. So that's what we're doing. I will give a demo of that late, just after this presentation. So the second example here I'm taking is extracting some face. So when we extract the face, we do the same thing. So just notice that I'm using the same document image here. And beforehand, I defined this face detector. It's like an extractor. Instead of using a text extractor, it's like before we're using a face extractor. And this extractor is going to use the document image pixel by pixel and apply the algorithms to detect all the faces. It doesn't detect only one. It detects all the faces inside the image and make sure that it extracts it and give it as an array. And that's why here, what we're doing in the set, again, in this set state, where we're trying to extract the information from the result and use it in our use case. So make sure that, I mean, it extracts something. So the faces, there is some faces detected there, obviously. And then here, I mean, it's just a strong hypothesis. I'm using the dot first. It means that, yeah, okay, I'm supposing that, I mean, I'm always getting the first face, which is the most important one, which may not be the case in your use case, because the card I'm using has definitely one image, one face, which is the photo of the owner of the card. So based on this, based on the use case, you need to define how you extract the information. So that's why here I have just this dot first, assuming that there is only one single photo on the image, which is not quite the case, because if you go back here, you see the small one. So sometimes it happens, and of course you need to fix this issue by maybe detecting the size of the image, and you can of course go through all the images that have been detected, and then based on some heuristic, define which one you're going to pick, and of course use it as expected in your use case. Of course, here what we're doing, of course, this is just some technicality we have been doing in the example here. I will show you how it runs in real application in this presentation. So what we're doing, we're using some cropping and then just populating in an objectives detected Emirates ID info the face, and inside it we just loading the face that have been detected. Okay, let's do a demo. I'm going to go to, I'm going to share my screen here. I hope that you're seeing my screen. Okay, this is, I'm going to try to share my screen. Okay. I'm going to just share my screen of my phone, the screen of my phone. I hope you're seeing the screen of my phone. Oh yeah, I think you see it. So here I'm going to start this application here. Okay, this application, we've been creating it for one of our partners. This is in the KYC process. What it does, it sends you a PIN for the creation of the account, and then you need to go ahead and just enter. We suppose that we're entering this PIN, which is not really the case, but here, what we're doing here, we're using this OCR and face detection. Make sure that I'm getting it right. I think the light, the brightness is good enough. Okay, here it fails to detect like the ID number. It gets right my name, which is great, and the nationality is not, well, okay. Sorry for this image is not showing up very nice. So let's try again. It depends really on the brightness or the quality of the image. So I'm going to try another time. Okay. Oh, this time it's not. Oh, sorry. It's not even doing it again. Let's try. Sorry, guys. I do my best to get it right. So by the way, this application is still under development. That's why. Yeah. Okay. This time we get it right. Most of the information, all of the information indeed we are interested in. So the MLKit algorithms has taken a picture of my Emirates ID and extracted, based on the pattern, it's extracted the ID of my card. It's extracted my name without any error. Of course, this is the second time I'm trying, and extract my nationality, which is from Senegal, and it extracted the face on the card, so which is my picture. So here we're using two algorithms. We're using a text extractor and we're using the face extractor in the same application. And then once the user is happy, you can say, okay, proceed, and then do something else. So this is one of the real life example we are using, and we're using it for some other things like code bar or QR code scanning on other application in my team, and we've been quite successful and happy about the accuracy of the result, and it's amazingly fast indeed. So this was the demo. So I'm checking if you have some comments or some. Okay. A lot of things are in Arabic. I'm not sure I can read. So guys, if you have questions, let me know. Okay. I don't see that much comment. Yeah, if you guys, if you have any question or if you have any comments, let me know. I'll be more than happy to go back to any details you want to dive in, and I'll be more than happy. So to continue my presentation, I'm going to. Okay, before going to this last part, which is the TensorFlow Lite, I'm going to go back to the code. So those of you who are familiar with Flutter, so you know that the most important, let me close this, guys. Okay, no, let me just make it bigger. So the entry point of your application is going to be this pubspec.yaml file. And in this pubspec.yaml file, you're defining some assets, you're defining some library you're using. So here, in the context of MLKit, we're using mainly these 4 libraries, so these 4 modules. So a camera, of course, camera is used here to extract, to take the picture, just to take the live picture of the card. You can also use it I think you can also use it to pick an image from your gallery. So path provider is used just to create a temporary image inside the storage of your device. We're using the file-based ML Vision. This is a quite outdated library. So I think there is newer library than this one. And here we're using image. This image library is very handy. So because we're using it to crop and do some adjustment on the image and to get the right information. So it's mainly used for extracting the photo and doing some slicing of the photo. So once you define this library, because here I'm using iOS as an example, I'm going to open this pod file. And in this pod file, I'm defining in this application what are those ML vision algorithm I'm using. So in this application, I haven't showed you all the features of this application, but here I'm using, in this application, my team is using the barcode model. We're using face extraction, just like you've seen. We're not using that much label yet, but I think in the near future we can be using it. And of course, we're using this text extractor model. So this is how you define it when you're using an iOS device, when you're developing on iOS. So I'm going to this text I already showed you. So this text that extracts the name, the nationality, and the ID card is here. Let me know if you're seeing my screen right. I'm going to make it bigger. Okay, so here what I'm doing is very simple, quite simple to use here. The library is quite simple. So we're using this file-based vision image, and this file-based vision image is loading some picture that already have been loaded by the camera library. And once this is loaded, of course, here I didn't show you that much about how we load it and how we do the cropping based on some specificity of the iOS, because it's rotating somehow the image for some reason I don't understand yet. So we're doing some cropping. See, this cropping is really based on our use case. Of course, based on your use case, you need to slice and dice. You need to adjust some parameters in order to get this information you want to extract. You get it right. So that's what we're doing here. But the main thing we're doing with MLKit is loading the image here and creating a text recognizer once you create your text synchronizer, you need only one single line. Can you believe it? One single line to do the job, to extract all the information. I mean, all the text recognition information, OCR, as it is known. And then we go ahead by cycling through the blocks. And for each block, MLKit is detecting some lines, and these lines are basically lines of text. It can be English, it can be French, it can be Arabic. This is the beauty of it. So MLKit is smart enough, and the model is smart enough, even though the model is quite like small, relatively small, it extracts all this information and there are a lot of languages already taken into account. And once this information is extracted, we use this set state I already showed you, and then we do some cleansing and we extract the information here of the name. We extract the information of the nationality by doing some trimming, some replacement to get it right. And then finally here, which is the much like demanding part, is the extracting the ID of the card. So we define a pattern. So this pattern is for the Emirates ID card. So this Emirates ID card, this pattern, if you go into the presentation, is related to this number. Okay. So Bayes has already told you, based on your use case, you need to define the pattern, and you need to define some heuristic to slice and dice, and some heuristic to clean the information all around and have it right. So this is the first part. And then the second part is the face detection, as I already showed you in the presentation. So the face detection is creating an instance of the detector. And of course here, the instance of the detector is using this face detector options object. And this options object at the moment is only using one parameter. So there are much more parameters based on the capability. Let me show you. There are some enable. So here you have enable classification, enable contours, enable label landmarks, enable tracking. So these are some other capabilities that are a bit more demanding in terms of algorithms, in terms of computation. For example, the classification is using some other classification algorithm behind the scenes. It's like the Inception V3, which is like the well-known and very accurate machine learning algorithms for detecting a different object provided by Google, because it has been trained on so much data that makes it one of the most accurate in the pre-made or pre-trained model in the market at the moment, in the open source world, I would say, when it comes to the open machine learning pre-made model, pre-trained model. So we have contours, we have landmarks, we have tracking. So all these can be used. But of course, when you enable these, of course, it makes your model much demanding and much computationally intensive. So, okay, once you have your detector ready and parameters ready to be run, you can asynchronously with this await, we can face, detect, and process the image. And then the machine learning algorithm behind MLKit is extracting the information you defined so far in this option object. So here we're detecting some faces, and the faces are detected in this object. This is a kind of an array of faces, and this array of faces, you can just go through it and detect all the faces, or just extract one of them, just like I'm doing here. I'm just extracting the first one. And of course, again, it depends on the use case. And once this is done, I'm just gonna show the information. That's what you've seen inside the application. Let me see, do I have questions? Left comment, okay. Oh, security, yeah. Mubarak Sub, thanks for your question. Okay, security is like really a good point indeed. It depends. As I mentioned, MLKit provides you two flavors of running algorithms and of using the algorithms. Either you are on device, and of course, it's very secret, so because the algorithm is running in the device, and you have no chance that the data get outside unless you your application, the way you build it has some exploit. It has some vulnerabilities that people can use. So this is the first point. So in terms of security, of course, running the algorithms inside the device is totally sure, I would say. So the second usage, the second way of using MLKit is by calling a REST API inside in the cloud in GCP through Firebase. So Firebase allows you to use your data and, of course, train and run the model and give you the result. Of course, GCP is well known to be really, really strongly secret, and the security is not compromised at all. It's because, of course, I'm using a lot of Google tools. I may be a bit biased, but definitely the security you can have inside GCP I'm using on a daily basis is amazing. So yeah, so security-wise, I would say that it's quite secure. The security is really amazing, both on device and in the cloud. I have another question from Muhammad Ali, using MLKit in business for free. Oh, of course, yeah. It goes back to how you're using it. On device, it's totally free. Of course, you're losing some accuracy, but in the cloud, yeah, the first 1,000 requests are free, and then after that you need to pay based on the billing and based on the region in the world you are and where you are running your application. Of course, Mohammed Dawood, the question is, can you run the app offline? Of course, you can run on device, totally on device. So you have the model embedded inside your app, inside your device. Okay, so you have the model running on your device, and of course it is offline, because the application, the example I have just shown you is totally running on device without any internet connection. Inception v3, which is based on the CNN convolutional neural network, which is one of the best algorithms and that is using for extracting this information. I mean, for extracting for face recognition. In part of it, I would say, not all, because extracting of faces is not only detecting objects; it's much more than that, because you need to detect the patterns of the image of what is an eye, what is an ear, what is a nose, and yeah, of course, it's much more demanding than just detecting one object, because I mean, yeah, I don't know which one, but I would presume that it's using something like the CNN, much more sophisticated, of course. Yeah, I don't know if Mohammed Al-Makki, this answers to your question, but yeah, that I don't have that much information about that. But in my team, basically, we're using MLKit this way, but we also using MLKit another way I'm going to present. So the way we're using it, of course, is by leveraging TensorFlow. So I have a much more technical presentation about TensorFlow, but here I'm just gonna scratch the surface by telling you what is the overall use case, what is the overall way we're using TensorFlow in MLKit. So MLKit has pre-made and pre-trained models, and you can just use it just like we did in the application in Flutter. And the second use case, the second way of using it is by leveraging TensorFlow. And of course, TensorFlow models, when it comes to audio and photos and this kind of media data, the model turns out to be very big. You need to shrink the model to shrink it to the smallest size and not compromising that much accuracy. This is really important. So it's where TensorFlow Lite comes into the place. So TensorFlow Lite is this framework that allow you to bring a already built TensorFlow model and shrink it so that you can use it on device. It can be an Android device, it can be an iOS device, it can be a Raspberry device, and an IoT device in general. So it gives room to a lot of creativity and a lot of most of the application that can't afford having some machine learning algorithm running in the cloud and calling it, they can definitely use it for this reason or another reason, like the privacy, as I mentioned so far. So when privacy is really can't be compromised, and it doesn't mean that in GCP there's no privacy, it's absolutely wrong. When your use case is totally disconnected and you need to connect devices between them and you need to run some algorithm, of course you can use TensorFlow Lite to use some already made algorithms, already made models inside TensorFlow. So the typical way of developing these algorithms, that's what we're doing in our team, is we take in TensorFlow 2, or TensorFlow in general. Of course, now Keras is one of the high-level API that sits on top of a TensorFlow that makes it easy, amazingly easy, to develop and use some algorithms and some models. And we're using Keras. Either we can use a pre-trained model, or you can use a model from scratch, which is not that much recommended when it comes to photo, videos, unless you are really doing some research and development, or some research and some academic research. Most of the time, in the use cases in any industry, in any use cases, people are often the case using a pre-trained model, and then use this pre-trained model, save it as a model. Most of the case, they're using a protocol buffer format, and this protocol format is then used by TensorFlow Lite to be shrink and then be used inside the device. So this is how TensorFlow Lite is working. TensorFlow Lite. So this framework. So I think I have 15 minutes left. So just quickly, so you can take any model, between quotes, any model. You can take a TensorFlow model you already built with Keras, and then train it, save it, and then use TensorFlow Lite to make it so small that it can fit in on your device. Either a Raspberry Pi, it can be an iOS device, or any other like IoT device that can run this kind of model. Guys, I think that's it on my presentation. That's all I have for you. It was quite an introduction for you guys to tell you how you can use MLKit and what are different use cases, and just show you a real life application we are building for our partners, and how we're using it and how we even going further by using TensorFlow Lite. So guys, if you have questions, let me know. Let me check, and it's based on the camera sensor to detect the object. Okay, I have another question from Mohammed Al-Maki. So yeah, his question is it based on the on-camera sensors to detect the object? Yeah, I mean, the algorithms is just taking the images, it's taking the frames of images that coming to the sensor and just applying an algorithm. So a simple CNN can, between quotes, it needs to be more sophisticated, of course, because most of the time, if it is a video, you need to use an LSTM to put it in a stream, and then this stream has to be has to use some extractor, some pattern extractor like CNN, and do some other stuff much more complicated. Of course, yeah, here MLKit is only using the camera as a sensor to do the job. Oh, okay, yeah. Mubarak sir, sure. I will be sharing with you guys some part of my code. Of course, I will not be sharing. I will not be able to share all the code. Of course, I will be sharing all the part related to the MLKit part, and then on the GitHub, on my GitHub, for you to use for sure. Yeah, for sure. I'll be providing it for sure. I haven't pushed it on my GitHub yet, but for sure I will create a dedicated a Flutter application just for this application for you to use. I think we have a couple of maybe 5 minutes left. If you guys can. Okay, that's it for me. But yeah, waiting for the hand. I'm more than happy. I'll be more than happy to answer any question I have information about. Yeah, you can ping me on Twitter. So Salim, thanks for okay, this is my Twitter handle, at Ndjido. So you can ping me. So if I forget the GitHub, of course, the organizer would not forget at all. So if you have any question, just feel free to tag me, to ping me on Twitter. I'll be more than happy to answer your questions. Okay, guys, it was a great pleasure. This is information I will definitely come back with much more information, much more like a presentation on TensorFlow, on developing algorithms in TensorFlow, different AI models in TensorFlow. So make sure that you get my Twitter handle, Ndjido, and like I'll be more than happy to answer your questions. And okay, thanks for you guys. Okay, guys, thanks.